We now look towards the heading integration by the method of substitution, which is of course the crucial part of all the other types of process. Almost in every process, this simple method of substitution is involved. Even the previous discussion, integral of f of x plus b dx is equal to capital F of x plus b by a, we could have used, isn't it? In that process also this method has been involved. What I mean to say is, suppose integral of 2x by x square plus 1 whole to the power of 4 is there. It is not in the standard form. You observe the steps. Let x square plus 1 is equal to t. Differentiate with on both the sides. X square plus 1, its differential is 2x dx is equal to dt. Let me name this integral some I. So I is therefore equal to, in the place of 2x dx we can have dt, and in the place of x square plus 1 we can have t. It looks like 1 by t power 4. 1 by t power 4. What is its integral? Minus 1 by 3t cube, isn't it? Previously we could have had the formula integral of 1 by x power n dx is minus 1 by n minus 1 into x power n minus 1, isn't it? According to that, it is therefore equal to minus 1 by 3t cube plus c. And in the place of t we use of course x square plus 1. Hence this is minus 1 by 3 into x square plus 1 whole cube plus c. This is the matter. We could have substituted t for x square plus 1. The thing that must be noticed is, when can you substitute a particular thing as t? What are all the necessary conditions there which are suitable? A particular function can be assumed as some t or some other thing when and only when its derivative is just available before dx. We could have taken x square plus 1 as t because its derivative is available here. If it is x cube plus 1, you cannot apply this method. You must seek another method because derivative of x cube plus 1 is not 2x. Of course, you can do one thing. If x square plus 1 is here and if 2 is not present here, what happens? Derivative of x square plus 1 is 2x, or the 2 is not present. What can you do? You need not worry about that. 2x dx is dt implies x dx is half dt. Or you supply 2 here, isn't it? Then also you can use it, isn't it? This process of integration is nothing but called integration by the method of substitution. Using this methodology, using this method of integration by the method of substitution, to have the answers on this part, we design for ourselves some beautiful formulas. Out of them, the very first one is integral of f dash x by f of x is log mod f of x. Its validity, its proof can easily be understood on this part itself. Why? Because if you take f of x is equal to t, automatically f dash x dx becomes dt. It is dt by t. That is integral of 1 by t is log mod t, we know. And in the place of t we have log mod f of x plus c. Yes, look here. Integral of x dx by x square plus 5. What is the answer? It is f of x. What is f dash x? 2x. 2 is not present. Don't get worried of it. This is 2, supply 2 here, cancel here. So that it is half into log mod x square plus 5 plus c. What is integral of tan x? Actually speaking, it is not a formula that has been derived. How? What is integral of tan x? It is I am multiplying with secant x and dividing with secant x. You observe, in the numerator we have f dash x, and the denominator we have f of x. F dash x by f of x is log mod f of x, that is log mod secant x plus c. Of course, this we could have had as a formula. Not only this, you imagine integral of cot x. What is cot x? It is very direct, cos x by sin x. You take sin x as f of x and cos x will be f dash x. F dash x by f of x is log mod sin x, that is log mod f of x, that is log mod sin x plus c. Therefore, this is the beautiful formula to have the answer immediately. Okay, what is the integral of e power x minus e power minus x by e power x plus e power minus x? No steps are needed, no style of thinking is needed. F dash x by fx, that shape it could acquire. You take e power x plus e power minus x as f of x. Automatically the numerator will be in the shape of f dash x. You can observe, isn't it? So it is in the form of f dash x by f of x. What is the integral of f dash x by f of x? Log mod f of x. So this is log mod e power x plus e power minus x plus c. Plus c. What is integral of 3x by root 4x square plus 5? We can take 4x square plus 5 as t. In its derivative we should have 8x, but only 3x is there. The part containing x's is present, no problem. We are worrying about the constants only, no problem. What is the derivative of 4x square plus 5? 8x. So you must have 8x in the numerator. That's all, isn't it? It's very simple. It is 8x by 4x square plus 5 dx. Actually 8 is not here. We have provided it. So cancel it. Already 3 is there, but 3 is not here. You pull 3 out so that it is 3 by 8 into. Now this is, it is in the form 3 by 8 into, this I am supposing it to be t. This is dt by root t. What is the integral of 1 by root t? It is 2 root t. Hence, you see it's 3 by 8 into 2 root 4x square plus 5 plus c. So it is 3 by 4 into root 4x square plus 5 plus c. Good, next. Integral of f dash x by root f of x dx is equal to 2 root f of x plus c. Another fruit from the tree of integration by substitution. Yes. You take f of x as t. F dash x dx is dt. dt by root t. dt by root t is nothing but 2 root t. Okay. Come on. What is the answer? This is 1 by x into root of 1 plus log x dx. I would like to have the answer. What is f of x and what is f dash x here? What is f of x? 1 plus log x. What is f dash x? 1 by x. It is not there. You observe it? It is there. You can take this x to the numerator to write 1 by x here. So f dash x by root of x. It is appearing in that form. Hence the answer is 2 root 1 plus log x plus c. Plus c. One more thing. It is e power x by root of 3 plus 4 e power x dx. Come on, what is the answer? What is the derivative of 3 plus 4 e power x? 4 e power x. 4 is not there. You create, no problem at all. So it becomes 1 by 4 into. This is therefore 1 by 4 into. Come on, tell me. F dash x by root of x. f dash x by root of x is nothing but 2 root of x, that is 2 into root of 3 plus 4 e power x plus c. Hence it is half into root of 3 plus 4 e power x plus c. Like that. We could have created this. Actually, it might not be available in the textbooks. For our needs, to fulfill the needfulness, we for ourselves could have created this. Like this, there are so many other things. You now observe one of the most standard formulas. Integral of f of x whole to the power of n into f dash x dx is equal to f of x whole power n plus 1 by n plus 1 plus c. Imagine its proof and validity. How simple it is, we can enjoy it, of course. How can it be proved? If you can take f of x equal to some t power n dt. What is the integral of t power n dt? T power n plus 1 by n plus 1. That's all. It is appearing like that. And there is a wide range of applications for this formula. You observe integral of sine to the power of 5x into cos x dx. Come on, what is the answer? You take this as f of x, automatically this is f dash x dx, hence this is, what is that? F of x is sine x, f dash x is cos x, f of x whole power n. In the place of n, we have 5. So the answer is f of x whole power, that is sin x whole to the power of 5 plus 1, that is 6 by 6 plus c. The strength of this integrand is cos x is present. If cos x is not present, you may have to have a reduction formula for integral sine power on x. It has a lengthy answer and a long procedure. Of course, we shall discuss with it later in the next session, most probably. Right? Integral of sine power 5x into cos x is like that. Well done. Integral of sine inverse x whole to the power of 6 by root of 1 minus x square dx. Come on. Sine inverse x whole to the power of 6 by root of 1 minus x square dx. What is f of x and what is f dash x here? That's all you may have to know. It is f of x is sine inverse x and f dash x is 1 by root 1 minus x square. It is just beside dx, isn't it? So no problem. You can utilize this formula. You can encash this formula. So that it is sine inverse x whole to the power of 7 by 7 plus c. Likewise, we shall have so many applications to this. Integral of log 1 plus ax whole to the power of 7 by x dx. A is positive, of course. A is positive. It has been given. What is the answer? Come on, this is the function. And what is the derivative? 1 by 1 plus ax. Is it available? Is it available? No, it's not available. It is not available, isn't it? Then 1 plus ax, you take it as t. Otherwise, of course, from there also we will be using the integration by the method of substitution. I shall give you. Come on, what is its answer? F of x whole power 7. What is the derivative of log 1 plus ax? 1 by 1 plus ax into a must be there. Is it there? No. So you just offer into a 1 by a. So that it is 1 by a into log mod 1 plus ax whole to the power of 8 by 8. by 8. Good. Next one. Integral of f dash x by f of x into root f of x dx. You can imagine the answer. Very simple. One thing is sure. I am supposing f of x is equal to some t. F dash x dx is dt. So what type of shape it could acquire? dt by t root t. dt by t root t. What is the integral of 1 by t root t? What was the integral of 1 by x root x? Minus 2 by root x, isn't it? Here it is minus 2 by root t. That is minus 2 by root f of x. Minus 2 by root f of x plus c. This is the beautiful formula. My dear friends, actually speaking, there is no end. There is no end to construct such formula. For every need, we can create a formula. But it is not the case with us. For those problems in which the expressions are more frequently observed or occurred, we create a formula. Now this is integral of f dash x by f of x into root f of x is there, and it can be converted to 1 by t root t. 1 by t root t, its integral is minus 2 by root t. Therefore, it is minus 2 by root f of x plus c. Well, look here, integral of 1 by x into 1 plus log x into root 1 plus log x. What is the answer? What is f of x and what is f dash x here? Here f of x is 1 plus log x and f dash x is 1 by x. So it is f dash x by f of x into root f of x. The same shape it could acquire. Hence the answer is minus 2 by root f of x plus c. Minus 2 by root f of x plus c. Well, therefore, this is also a useful formula. Let us now apply one more such thing. Come on friends, you please try to guess the answer for this. How to guess it? As usual, we shall be considering f of x is equal to some t. What shape it could acquire? It acquires the shape of f dash x by, that is a dt by t square. As f of x is equal to t, f dash x dx is dt, hence it is nothing but dt by t square. What is the integral of dt by t square? Come on, minus 1 by t. Why? Because integral of 1 by x square is minus 1 by x. Integral of 1 by t square dt is minus 1 by t. But in the place of t, what are you having here? F of x. Hence the answer is minus 1 by f of x plus c. Minus 1 by f of x plus c. Let us observe an example. Integral of x square dx by 4x cube plus 1 whole square. This is the integral given. I like to take this 4x cube plus 1 as f of x. In order to use this formula, I must be provided with f dash x in the numerator. What is f dash x? 12x square. Is 12 happening here? No. You create, what is that? What is that? What is that? This is therefore 1 by 12 into 12x square dx by 4x cube plus 1 whole square. Just to understand immediately, only I could have put this step. Actually speaking, you need not put this step. You can have the answer directly. Come on, f dash x by f of x whole square. It is minus 1 by f of x. Likewise, there might be so many occasions, so many needful situations where you can use this formula. And as I said just now, there is no end to this procedure. There is no end to the style of creating, constructing such formulae. Always we shall take f of x is equal to some t, and we pick out those formulae which are very famous, which are very useful, and in which the functions, rather the expressions, are more frequently observed in the problems in which we come across. Yes. Now, as we just discussed, there is no end to this procedure. As and when a needful situation is before us, we create on this part, which is to be supposed as t or some other thing, some other substitution. Okay, right. And in this process, there is another angle of observation. What I mean to say is, you calculate integral of 1 by x minus 1 into x minus 2 dx. X minus 1 into x minus 2 dx. Here, the denominator is a reducible function. It has already been reduced as two factors, x minus 1 and x minus 2. We can now use partial fractions so that this product of in the denominator can be split into two fractions. That is what we mean actually by the word partial fractions. That is, we are now ready to switch over to the topic integration by using partial fractions. That is the heading before us.